Hey guys, it's Captain Wolf here, and this video is going to be about Windows access tokens, why they are used, and also about impersonation and why Windows does it, and how we as penetration testers or CTF players can leverage this behavior of Windows to elevate or maintain your access, whatever. And I have here a list of things that we need to discuss today. So let's start our discussion with what are Windows access tokens. So I am here on VM running Windows 7. Sorry guys, I can't demonstrate it on Windows 8 or 10 or whatsoever because my machine is not that strong enough to run Windows 8 VM or anything above that. But the things I'm gonna demonstrate and show will work the same way in whatever version of Windows you are using, because this is something that is at the core of Windows and has been existing for a long time now. So let's go over something I would like to show you guys. The first thing I'm going to discuss is what are Windows access tokens. Let's do a little demo. I'm going to open up command prompt here and I'm going to type, let's say, who am I? I'm going to show you something. See, access tokens are something that are given to the users who log into their system. The moment that they log in with their password and credentials and whatever the thing that is, they're given something called as the Windows access tokens. Access tokens contain a load of information. You can see here in this MSDN page that I opened up that access tokens contain a host of things. Scroll down and you will find this DSID for the user's account. Basically what these things are, in short, are that it identifies the users as well as their privileges on the system, plus it contains the default DSCL, and these are some of the most important things that are present inside an access token. And in addition to that, one little thing I forgot are the list of privileges that are held by the user. And tokens, whenever you log in, these tokens identify yourself to the system. The system knows that which user is using these tokens because these tokens contain this SID for the user's account. Privileges are something that Windows uses in order to determine whether you are authorized to do something on the system, and DSCLs, or any form of ACLs for that matter, simply describes your right over any secureable object. Every secureable object in Windows has something called the security descriptor. In short, what this is that it simply tells what modification or access rights you have over an object, whether you have read access, write access, modifying access, and so on. We'll go over this little thing here, primary and impersonation tokens, and what this thing is, as well as impersonation, but in a short while, not now. So that is what access tokens are. What next thing do I have? Okay, why are they used? Well, as I said, access tokens, see, whenever users log into their system, the system needs to know who is running the session, right? So access tokens do exactly that. And in addition to that, they also contain the privileges and stuff. So access tokens are very much important to Windows. Linux does things a little differently. So this thing is unique to Windows. Next up we have, okay, let me give you a little demo of what access tokens actually mean. So here I have this command prompt here. You can see that currently I'm running as this administrator user Wolf, but since I opened the prompt with no UAC, you see that I only have a limited set of privileges on the system. So even though I am an administrator, I do not have much privileges right now in this shell. So whenever you start a new process, be that a command prompt or whatever the process that is, remember this, it receives the access token that you received at the time of login. What I mean to say is that, for example, let me close this again. Let's say I run CMD, and the moment I run this, what happens is that while creating a new process, Windows assigns this new process the copy of the access token that you received when you logged in. In other words, this process here is running with a copy of the access token that you received while you logged in. And also, any processes that are started by any of the parent processes that have your access token will also get a copy of that access token if you have inherit handle turned on. I know this is a lot to take in, so let's just take it slow. I'm getting too ahead of myself. So This command prompt was, let's use it to open calculator just for an example. If I open calculator here, this command prompt is running under my user woof, and if we go to task manager, we can see that this calculator is also running with woof, and the way that this happens is because calculator was started by CMD, which is running with a copy of my access token, woof's access token. So whenever this command prompt started the calculator, it also got a copy of the same token, and therefore it is also running under the same user woof, and this is how Windows manages it. Quite unique and sleek. Anyways, let's close the calculator. So this is just an example. Any process that you start on the computer, unless otherwise stated, runs by default with a copy of your access tokens. Next up, what do we have here? Types of token. Yeah, important thing. See, whenever you log into your system, there's two types of tokens that you get. One is the primary token and the other is impersonation or threat tokens, whatever you call it. These two tokens, although they show the same user, have a different set of usages. Let me open the command prompt again. And see, whenever you start a process, what happens is that alongside the process, a couple of threads also open up. Now the number of threads depend upon the process that is executing those threads, but by default every single process has at least one thread associated with it. So primary tokens are tokens that are owned and used by the process. Remember this, guys. Primary tokens are something that the process has and it uses. However, when the thread that is run by the process needs to use the access token, it cannot use the primary token. What it does instead is that it uses something called the impersonation token, or you can call it informally as the thread token. What the thread token or the impersonation token does is that it is kind of a copy of the primary token, and whenever a process needs to create a thread, the process will first create a copy of its primary token, but in impersonation mode. So you get an impersonation token instead of the primary token, and then using that impersonation token, you can now assign that to a newly created thread or an already existing thread in suspended mode. And basically you can use that token. Then I'm getting a tool ahead of myself, sorry guys, but I will shortly demonstrate what I mean, how processes do that, because in this next part of the video, I think this video will be long enough, so I need to make a second video, I guess, on how to do the token impersonation, how to write a program that does it. For now, let's go on to the next topic. So what is impersonation now? The main topic of our discussion. What is impersonation, and why did I talk about a shitload about tokens and stuff? What is impersonation? Let's jump to that topic. So let's say that for now in this machine there's only one user woof running here, but for the sake of our discussion, let us assume that there's another user, let's say meow, running on the system, let's say, and you are the administrator. Woof is the administrator and meow is some other low privileged user. Now let's say that you need to access the system but as meow while staying as woof. So let's say you are woof but you need to pose as meow to the system, and the way that Windows or you can handle that is by doing something called as impersonation. Impersonation is when you take someone else's access token and use it to impersonate the other user. That is why the knowledge of access tokens is so useful, because they are what is used while impersonating a client. And why does Windows use that? Roll-up tokens and impersonation. So let us discuss that. See, as I said, that Windows tokens are something that are used to authorize or authenticate or identify yourself to the system. So if you have the access token of some other user, doesn't that mean that you are changing your identity on the system or impersonating a different identity? And the answer is yes, you are. When that happens, it is something called impersonation, and Windows does it all the time. And why is it required? Let me take you to the task manager to show you something. Here I have a list of processes running on the system. Let us go to, okay, this is Windows 7, yeah, I forgot. So a couple of processes, only a few are running on the system, but you see that some of them are running under woof and some of them will run under different users. If you have a server on your machine, it will run under the low privileged server user. If you have other processes running simultaneously on the system under different users, you will also see them listed here. And what Windows does is that sometimes it requires an already running process with a different user to impersonate as a different user. So for example, if Meow was running a server, let's say a SQL server or anything, and that server was listed here, and the server required whoever was authenticating to it to have some access to some data on this system, the server would first see whether you are authorized to see the data, and the way that it does is that for a moment it stops being Meow and it takes the access token from you, from the WOOF user, after you authenticate to it, and with your token what it does is that it impersonates you to do something on the system. And the reason why Windows does it is because it is quite secure. If you think about it, the only way you can get or identify if someone has legitimate access to the system is that if you have their tokens. Because if you have their tokens, you have something called the security descriptors present inside the token that you can match with these systems. If it's a securable object, you can match it with the different ACLs, or maybe if you are running some operation on the process, you can see the privileges, and these tokens can tell the program whether the authenticated user is allowed to do something on the system. So that is why tokens are so important, and that is why you need to impersonate a second user or whoever the user is at that time in order to know whether you are allowed to do something on the system. And let us see what's the next discussion is. Okay, so the types of impersonation tokens. This is something very important because it will help us in order to impersonate stuff. You must know what different kinds of impersonations can be done. So by default, not by default, I don't think there are more than 4. No, there are 4 different kinds of impersonation tokens that are available with Windows. And mind you, when I say impersonation tokens, I do not mean threat tokens. Now this is why this confused me for some time when I first started learning about this, is that the first time when I said that access tokens are 2 types, primary and impersonation, this is different than what I am talking about here, although they have quite similar names. Primary tokens are used by processes, impersonation tokens are used by threads, and that is the beginning and end of it. Here, well, when I say types of impersonation tokens, I do not refer to primary tokens or impersonation tokens in general. I refer to any sort of tokens here. And there are 4 kinds. There are 4 kinds of impersonation tokens that are used by the Windows. The first one is security identification. Let me show you guys the first one. Where is it? I kept it. Yeah, here. Let me zoom in. There are 4 types of impersonation. The first one is security anonymous, and as it says, if you use this kind of impersonation level, then you cannot identify who the current user is, who is using your service or your program. The server here refers to any program that is currently looking to impersonate a user or a client here, as in this case. So security anonymous level does not allow you the impersonation or even identify the client, as it clearly states here. Security identification level is the next higher impersonation level, and it allows you to, as the name says, identify the user, but it does not allow you to impersonate the client. In other words, although I never tried it, but I think if you impersonate a user with the security identification level, it will give you the identity and the privileges and stuff, but it will not help you to impersonate, maybe to pose as the user. Yeah, that must be it. When it comes to impersonation for us penetration testers, these 2 levels are not that much important to know about. These 2, on the other hand, they're everything that you must know about when it comes to impersonation. See, security impersonation level of impersonation, this is where Microsoft even makes me confused. Security impersonation level helps you to impersonate a client. The important thing to know here is this little thing. On the local system, which means if you are impersonating on the security impersonation level, you can only impersonate those users on the local system only. So if you are on a workstation and you have impersonated someone over there, you can only impersonate and keep your impersonation and privileges and stuff only on that local machine. If that user has its account on some other computer as well connected to the same network or whatever, you cannot impersonate over the network on some other workstation. You can only impersonate that user on that local system. This is what this level of impersonation does. The fourth level of impersonation is security delegation, the highest impersonation level, and this does what security impersonation does in addition to being available for remote systems as well. So security impersonation couldn't impersonate any user over the network, over to some other workstation, but security delegation can do that. So this is impersonation levels. Let's see what next do I have. Types of impersonation tokens. So in my next video, I'm going to show you how you can write a simple token impersonator and how different programs, different legitimate programs actually use those, and how you as a penetration tester can write your own programs. If you must have seen programs like Metasploit's Incognito or something that does this exact same thing. It enumerates the process tokens and then allows you to impersonate any one of them. Incognito, writing the name wouldn't be enough. Maybe it's some. I have never been able to track who's the creator of Incognito. There are so many of them. But, sorry guys, I'm just drawing out this video. In my next video, I'm going to go over the code I wrote, and every code that I'll talk about will be in my repo. So maybe follow the channel. I don't know. It's my first video. I don't know if I'm going to be regular. But, alright guys, see you in the next video.